Let me tell you something really quickly about our test on Friday. So part of our test, you're going to be doing some old stuff from semester 1. That's at the beginning, and it's not very long. And then you're going to do some graphing where you have to graph and solve by graphing. I think there's 2 of those. One of them, like the equations are already y equals mx plus b. One of them, the equations, you have to like set them up before you solve them. You guys know what I'm talking about when I say that? We'll see some in our assignment today. But then you get into solving systems algebraically. There are 9 problems you're going to do on the test. So at this point, you're probably halfway done with the test, and you got 9 problems left to go. Okay, now let's say most of you, when you get to this point, you're still going to have like an hour left in the period to solve those 9 problems, which is plenty of time. The first 3 problems, I'm going to tell you, the first 3 problems, I'm going to tell you how to solve it. I will tell you to use equal values, use substitution, use elimination. And those 3 problems are worth 18 points out of your 100 for the test. So 6 points apiece. And mainly what I'm grading there is, can you follow the correct steps? So you need to know how to do these 3 things. And then the other 6 problems you're going to solve, it's going to be all on one page, and up at the top it's going to say, solve these using whatever method you want. And you're going to get to choose, do I want to use substitution or elimination or equal values? So really quickly, I just want to practice doing this right now. These instructions say do not solve. All I want you to do is look them over, and if you were going to solve them, which of these 3 methods would you use? Like, so for example, in this first one, would you use equal values, substitution, or elimination for this first one? Which of those 3 would you use? This would be an equal value problem, for sure, for sure. How do we know it? What do we recognize about this problem? You got 2 equations that both say either y equals or x equals. That's when you do equal values. That's when we know we can take and stick this thing equal to this thing. Put those 2 things in our equation with an equal sign in between. This is an equal values problem. How about B? Is that equal values also? No, because it doesn't have 2 equations with y equals. Only 1 equation has a y equals this time. Which one would this be? This would be a better one for substitution. We could take that x minus 1 and substitute it into the other equation in place of y. So this is a substitution problem. Can I get you guys to go through the rest of those 9 problems and just write down which of those 3 methods do you think would be the best one to use to solve it? You don't have to solve any of them. Just write down what you think the best method would be for each of those. What'd y'all think for C? This looks like equal values to me also. What about D? This is more of an elimination problem. I asked you not to solve it, but what would you multiply that bottom equation by to eliminate? 3 would get us a 15x and a negative 15x. Yeah, this is an elimination problem. What about E? That looks like substitution. I'd probably take this and stick it in for y in the second equation. That's a substitution problem. What about F? F is elimination. Would you be multiplying your top or bottom equation by something? Bottom one by negative 2. Negative 2 would get us a positive 18y here, and that would cancel with that negative 18y. Good. G, this one's kind of tricky. It's equal values. It's kind of a weird one because they're both x equals instead of y equals, but we'd do the same thing. We'd take these 2 things and stick an equals in between them. That's an equal value problem. H is an elimination problem. Would you be eliminating the x's or the y's, or dealer's choice? Dealer's choice. Yeah, I could get rid of the x's if I multiplied, let's see, I could multiply that by 6, and that would get me a negative 12x. Or I could multiply this by 3 and get me a negative 9y. So we got options there. This last one, is that looking like substitution to you? I'd stick that in for y in my second equation. All right. let's go back one page, and then we'll come back to this page in a minute. Our focus today is on applications, aka word problems. So I'm going to tell you, I'm going to take a couple little notes up top here. Most of the word problems that we're going to do in this unit are going to fall into one or two styles. Some of them, and we've already done a bunch of these, look like this, where we write equations that are going to be y equals mx plus b type equations, where m is some change and b is some starting value. You guys have done problems already in this unit where m was 2 meters per second and b was a 6-meter head start. It was like a tricycle race with Gia and Bruce. Do you guys remember doing problems like that? You did some where like somebody was saving up money and they had this much to start with and they were saving up $25 a week or something like that. You guys remember doing those? And then you try and figure out when do those two things match up. So we've done a bunch of these. There's another style of problem where you have sort of categories of things, and that's mostly what we're going to be dealing with today. And for these categories, usually you're going to end up writing a couple equations that look like this. One of them will typically be x plus y equals something. And the other one will be kind of the same thing, but there'll be some numbers being multiplied by x and y. So when you're doing your word problem on your test, the first question I want you asking yourself is this something where I have a starting value and a change, or is this something where I got a couple different categories going on? So let's read the first question and see what we think. A play costs $9 for adults and $7 for kids. 63 people attended the play. Total ticket sales were $487. How many adults and kids attended? Does this seem like something where we've got a start value and a change, or something where we've got two different categories going on? This seems like two different categories. And what are my two main categories? Kids and adults. So I'm going to write that down, kids and adults. And we're going to set up some variables to represent kids and adults. Do you guys want to go with K and A, or you want to use X and Y, or how do you want to do this? You want to go K and A? So I'm going to say K for kids and A for adults. That makes sense, right? Now, if you're more of an XY kind of person, just write it down. And this is an important step because especially if you're using X and Y, it'll help you get the correct number with the correct category at the end of the problem when we answer the question. And let's write an equation. So we've got two things going on aside from kids and adults. I'd say this is about kids and adult what? Kids and adults clothing, kids and adults. It's a play, yeah, they're tickets, right? There's kids tickets and there's adult tickets. So, and then there's also money going on. So I'm going to write two equations. One's going to be for tickets and one's going to be for money. All right, let's write an equation for tickets. K plus A equals, if K and A are the number of tickets that kids and adults bought, if we add up the total number of tickets, the kids' tickets plus the adults' tickets, what number are we going to end up with in this situation? Say it again. If we add up the number of tickets, is it 9, is it 7, is it 63, or 487? What is the total number of tickets? I'd say 63 is the total number of tickets. They didn't sell 487 tickets, did they? I'd say they sold 63 tickets. I'd say the 487 would be my total for the money equation. Would you agree with that? That makes sense because their total money that they brought in was $487. See if you guys can figure out what are my coefficients going to be for K and A. What am I going to multiply by the number of kids, and what am I going to multiply by the number of adults? What do you think I'm going to multiply by the number of kids? 7, you think? 7 times the number of kids, that would give me the amount of money I made off of the kids, right? And then if you're using the 7 for the kids, I bet you're using 9 for the adults. Is that right? 9 times the number of adults, that would give me how much money I made off of the adults. So the money I made off of the kids plus the money I made off of the adults, total would be 487. Does that make sense? Cool. That's our system. All we got to do is solve it. Now, the nice thing is, once you get these things written, they're actually pretty easy to solve. You might want a calculator out because the numbers do get big. Y'all want to eliminate the K's or the A's? No wrong answer here. K's, okay. That means we're going to need to multiply that top equation by something to get my K's to cancel out. -7 sounds great to me. That's going to leave me with a -7K. So I'm transferring down here. -7K, and then that would be -7A equals, and then 63 times 7, oh boy, 6 times 7 is 42, so that's 420. 60 times 7 is 420, and then 3 times 7 is 21, so 420 plus 21 is 441? Nice. Still got it. And then the second equation stays the same. And then we add them up. K's are going to go away. Woo! How many A's we got left? 2 A's. And then someone help me out with -441 plus 687. Or plus 487. 46? Cool. That'll divide by 2 pretty easily. A equals half of 42. 46 is 23. 23 adults, right? That's what A is. 23 adults. Normally we would take that, plug it back into one of those equations, but I bet you guys can do this in your head. How many tickets were sold altogether? 63. If 23 of them were adults, then how many were kids? 40. All right. So I want you to get a little practice with this style of problem. You're going to see some more of the y equals mxp type problems in your assignment. What I'd like you to do right now, I'm going to give you about 10 minutes for this, is see if you can tackle problems 2 and 3. If you are interested, I'm going to use X and Y for these. I'm going to give you a little hint here. Your first system for number 2 is going to look something like this. See if you can find numbers to fill in those blanks. The one for number 3 is actually going to look a lot like this as well, with one small difference. If you don't want a hint, if this is a spoiler for you, then don't listen right now. Or actually, I won't say it out loud. I'll write my hint down here. And I'll leave this up on the screen, so you don't need to worry about writing it down. All right, let me give you about 10 minutes. We'll come back together, check our answers. If you need any hints to get you started, please get my attention. If anybody's interested, guys, if you're working and you're feeling pretty confident about this, keep going, but do it quietly. Shh. If anybody's interested, these problems, we did this one up here with elimination, but they can actually be done using substitution. And some of you are more confident using substitution than elimination, so let me show you how to do that. All right, so depending on how you wrote this, if X is onions and Y is parfaits, this should be our system. Guys, if you're going to work without paying attention, then stop the talking, please. Thank you. I'm fine with you ignoring me and just working, but let's not be chatting. What I'm going to do is I'm going to rewrite this equation over here. And I'm going to either get x or y by itself. That should be pretty easy to do in this equation because it's already got just an x and a y. Since we were working together, what do you want to get the x by itself or the y by itself here? The x, okay. So I'm going to just go minus y on both sides. That's going to get me x equals 11 minus y. And now I can use that to substitute into my other equation. I'm going to have to substitute it in place of my x. So let me rewrite my other equation. It was 2x plus 8y equals 52, but I left the x out because in place of the x, I'm going to put this 11 minus y. And now I can use substitution to solve that instead. You see how that works? So you can use substitution on a system that looks like this. You just have to do one extra step and take your easy equation, your simple one, and get either x or y by itself. And then we could go ahead and solve this the normal way. That'd be 22 minus 2y plus 8y equals 52. I'm going to run out of room here. We can put these together. The second one, I'm just going to put the answer up here. I'm going to give you guys a couple more minutes, and then we're going to come back together and just do a couple problems from the reverse side. All right, a couple more minutes.